translations in the coordinate plane. And we're looking at a rigid motion, okay, which was one of the last things that we learned about in our Unit 2, and that was the idea of the translation. Okay, as well as to describe it, it's simply described as a shift in the coordinate plane. So if we're looking at exercise 1, they give us that the segments A with -2, -8, and B 7, 4 have been graphed for us within this coordinate plane. Okay. What they want us to do is to translate, or translation, of 5 units left and 3 units up, and it tells me to label it as A prime, B prime, which is our signal that we need to graph this. It also says to draw it. Okay. Now if we think about 5 units to the left, all right, so if we actually move this 5 units to the left, 1, 2, 3, 4, 5, and then 3 units up, 1, 2, 3, we can see where the A prime is going to go. So when we moved it 5 units to the left, what we're actually doing is we're changing the x coordinate. The x axis actually moves from left to right. So as I move left or right, it actually affects my x coordinate. And if I look at the up 3, that was affecting the y coordinate, because that's how we move along the y axis, is the up and down. Right. So in other words, it's like, oh, I'm going to subtract 5 from the x coordinate, and I'm going to take my y coordinate and I'm going to add 3 because it said to go up 3. So that's what we're doing to the actual numbers. Okay. But graphically, I'm moving it 1, 2, 3, 4, 5 to the left and up 1, 2, 3. There's where B prime is going to go. Okay. And then it asks me to give the coordinates. So I'm actually going to draw in that segment because it says to draw. Draw the image AB once we've done that, and it uses this notation on top, which is this notation for segment. Draw the segment A prime, B prime. Okay. Now, we can easily get the coordinates off the graph for both A prime and B prime. So A prime is -7, -5. Which makes sense if we do it mathematically, that we take the x and we subtract 5, and we take the y and we add 3. Now when you do that, -2 minus 5, out comes -7, and if you do -8 plus 3, out comes -5. Okay. As far as b goes, we can look at the graph and see that this is 2, 7. And mathematically, subtract 5 from the x and add 3 to the y. Once we do that, 7 minus 5 is 2, and 4 plus 3 is 7. Okay, so that's how we do it both graphically and mathematically. Left 5, up 3, or subtract 5 and add 3 to the matching coordinates. Now it wants us to be able to calculate length. It does say using the distance formula, but we're going to use the other version of it, which is when we think about length or distance, I'm trying to figure out the length of a diagonal line. So I'm actually going to create the right triangle, up one more, to be able to use that idea, oh, this side is my A, and this part is my B. Okay. So what I did was I'm finding the rise and I'm finding the run, so I can create a right triangle to be able to use a squared plus b squared equals c squared. So to find length, I use the Pythagorean theorem. And if I count up, I get 12. That's my rise. So basically we're doing rise squared plus run squared. Okay, and I got 9 from just simply counting over 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes. The same way I got 12 is just because if I count the boxes up, that's 12. Okay. If you put that into your calculator, you'd get 225. And remember, the last step is to take the square root, which is going to give me 15, which is going to be the length of AB. And as you notice in the diagram, I connected A prime to B prime. So that's really A prime and B prime. But if I connect from A to B in the same manner, I'm going to get those same number. A rise of 12 plus a run of 9 equals C squared. So if I do all the math, because it's the same exact thing over here, I'm also going to get that 15 is equal to A prime B prime's length. Okay, so as you can see, they're the same. And they should be the same if we did it correctly, based on the idea of the vocab word back up here. Remember, rigid motion means same size, shape, length, and actually the angle. Okay, no angles are formed in this diagram besides the right triangles that we created, but there wasn't any angles to start. So they both came out to 15, and we should already know that because a translation is a rigid motion. Okay, so moving forward. All right, it asked me to calculate the slope of both AB and AB prime's segments. Okay, but we already did that. When we calculated the distance formula, we actually were doing rise squared plus run squared, and that's what the slope formula is rise over run. So therefore, the rise is 12 over 9. And in this case, I don't have to reduce it. It didn't ask me to reduce it. And the slope of A prime B prime segment was also 12 over 9. So if you remember anything from the previous unit, that actually makes these parallel because they are the same slope. So segment AB is parallel to segment A prime B prime because, now remember, this is the symbol for parallel, because they have the same slope. Okay, so looking at this next one, so we've done transformations before, and it says, like all rigid motions, again there's that word, translations preserve the same shape and size of an object. Okay, and it's also mapping so that it's parallel. So when we just shifted it up, it kept the same slope. Okay, so that's how we perform a translation. We're just simply moving it left and right, or up and down, and then plotting new coordinates. Right, in this second piece, it asks me that which of the following would map ABCD onto A prime, B prime, C prime, D prime, and then onto the double primes. Right, so if we take a look, we can kind of see that this indeed first starts off with the idea that it is a translation. So I'm just going to copy this little triangle or kite onto my paper. And we know that we're going from A, B, C, D to A prime, B prime, C prime because of the primes. So this was the first image. This is the second image, which makes this the third image because of the primes. Okay. So now, this cannot be a reflection because it's not flipping. It's actually just sliding to get up to here. So that's the idea of the lesson that we've been learning. It's a translation. Okay, so that's going to get rid of both 4 and 1. Only 2 and 3 start off with the first A translation first. Okay. But now that we're here, we've got to figure out how to get from the prime kite to the double prime kite. So we have to test. This is either a rotation or it's a reflection. Well, let's test the rotation. Okay. Now, if we're rotating, generally it's about the origin, so I'm going to place my pencil at the origin and try to turn this. Okay, so there's the rotation of 90. There's a rotation of 180. And as you can see, that rotation did not work. If it did work, this would be exactly on top of this, and neither is it here for the rotation of 180 and not for the rotation of 90. It's close to getting to here, but they only wanted 2 transformations. So guess what? That gets eliminated. It could not be the rotation. So now we have to think, well, okay, it's got to be a reflection, but how? Okay. Most people, when they think about a reflection, they're only thinking about the idea that it flipped. Okay, and for us, it's not a flip over the y-axis because the image would be here. It's actually something a little bit more specific than that. Right? Now, we studied in the reflections unit the idea of a line called y equals x, which is pretty much this line that goes down the middle here. So now I should, if I fold this along that line, this image should line up with here. Now remember, it's not always just the x-axis and the y-axis that we're reflecting it over. We do have other ones. So I'm going to fold this piece of paper on that line that I created and put it back down so that it lines up. Sorry, the x and y-axes that are here and here. And you can see that along this line that I folded it, the image did fold down to where it was supposed to be. Okay, so there's where the image, whoops, there's where the image was. And then if we fold it, if I did it correctly, which it's slightly off, is here. Okay, so that's how we do that. So it is a reflection. It's actually a reflection across the line of y equals x. And again, at y equals x is the diagonal line down the middle. And if we fold this, it actually lands on top of image 3. So a little tricky on that one, but process of elimination helped us there. Okay, moving forward. Okay, we didn't do exercise 3 in class, but I'm going to cover it in this video. We have a little bit more time. Okay, so given 2 different sequences of transformations that would show the 2 parallelograms to be congruent, so be as specific as possible. Right, so we want this quadrilateral parallelogram to make it up to this parallelogram. Okay, so there is a different possible ways to do this. So again, if we're tracing this onto our patty paper, one possible sequence is just to take this image and I'm just going to shift it exactly up to here. Okay, so if I was to count, C went up 1, 2, 3, 4, 5, 6, 7, and then back 1. So my first sequence was up 7, left 1. Now remember, when we move up, that affects the y-coordinate. And when we move left, that affects the x-coordinate. Okay. So now I'm going to write this in proper notation of a translation for capital T. And I'm going to do -1 to the x-coordinate, comma, and add 7 to the y-coordinate. Okay, so it looks like it's another coordinate pair, but they're really just trying to tell you to take the x and the y and change it into x minus 1, y plus 7. Okay, so now that I have my image where I want it to be, and again, that was here. Here was the image. Now what happens is that my second transformation would be a reflection over the y-axis. So if I actually fold this over the y-axis, what should happen is that this image should be on top of the other one right now. And as you can see, it is. My image landed on top of the other image. That's the reason why that's the only thing that we can see is the A, B, C, and D. So my second sequence, now this isn't the only sequence you can use, but it is one of them, was a reflection across the y-axis. Okay, and that was just one of them. So I just wanted to model what that would look like. Okay, on to exercise number 4. All right, reading this in the diagram shown, triangle EFG, can be mapped onto MNP by a sequence of transformations. Now remember, a sequence means more than one. Okay, it tells us that the first one is actually a rotation of 90 degrees. Okay, so I'm going to take this and I'm going to rotate it 90 degrees. Now I said clockwise, so be careful on that. And trace this image, G, E, F, and here's the origin. I'm going to rotate it 90 degrees clockwise. So remember, that's going to go to the right because that's the way that the clock moves. I'll line these back up and we can see where G, E, and F should go. So there's G, here's E, and here is F. Okay, so I'm going to label this as G prime, E prime, and F prime, because this was a rotation of 90 degrees clockwise. Okay, now I need to figure out how do I get from here to this image. Well, there's only a couple things that we can do, either translation, a rotation, or a reflection. Well, if I try to take this and rotate it another 90, it's not going to match. I'm upside down. Okay. All right, so rotation's out. Let's try to translate it. Nope, that's not going to work either. A couple of the points kind of line up, but these two definitely don't. Okay, so we did the rotation, did a translation. So the only other thing that I have left is the idea of a reflection. Okay, now remember, with the reflection, your distance from a point to the line of reflection should be the same as the image. So what I'm going to do is I'm going to count. There's 1, 2, 3, 4, 5, 6 boxes in between F and N. Now remember, F is going to be matched onto N. So half of 6 would be 3. So I'm going to count up 1, 2, 3, and then this way, that right there would be the middle point. So I'm going to draw a line right through that. And what happens is I'm creating the line y equals -2. If I was to fold the image across that line, I would map right onto it. Okay. So if I fold it across that line, I'm a little short on the patty paper, but if I did that, I would map right onto this where G matches with P, and that's what should happen according to here. If I number this 1, 2, 3, and 1, 2, 3, then G matches with P, F matches with N, E matches with M, and that's exactly what's happening. Here's E, there's M, and they match. So the second one was a reflection across the line of y equals -2. Okay, all Alright, moving on to the last one. Again, they're asking us for a sequence of transformation that will map triangle ABCD onto WXY. Okay. So I would have to test a couple of these. Okay, so let's attempt some of them, right? If I'm going to use the triangle ABC, there it is, and let's test this by rotating it clockwise 90 degrees. So I'm going to start here. I'm going to rotate this 90 degrees clockwise. Okay, you can see that I end up down here. And then if I need to, I'm going to try to reflect this across the y-axis. And if I do so, you can see that I do not line up at all. Okay, sorry for that interruption. All right, we left off on that I've reflected this over the y-axis, and what you can see is that the image ABC is not lining up with that one underneath. So therefore, it cannot be choice 1. All right, so let's go to choice 2. I'm going to go back to what I was doing, putting the original up on top, and it says to rotate it 90 degrees counterclockwise. So that's exactly what I'm going to do. Remember, that's to the left. 1 turn. Okay, so here's your triangle ABC still. And then a reflection across the line of y equals 1. Well, here's the line y equals 1. So if I folded that down onto that, you can see again the image does not line up with the image underneath. So therefore, it could not be choice 2. All right, let's move to number 3. Try that one out. Okay, number 3 first starts us off with reflecting over the line of y equals negative x. If you remember what y equals negative x is, it's this line that down the middle of the graph. Okay, so I would fold this along that line down the middle of the graph, and then I would translate it 2 units to the right, 1, 2 units to the right, and then 3 units up. 1, 2, 3. And as you can see, the images now line up. So therefore, that is the choice that we would pick by going through each one. Right? If you have any further questions, please see me in class.